right, so let's review the summary of transformations. So first of all, you must do reflections and dilations before vertical and horizontal translations. It's essentially PEMDAS, right? We multiply and divide before we add and subtract, right? So this has to be first, right? So after you've graphed, well, I guess technically first would be the parent graph. So we'll put first parent graph somewhere in here. Actually, I'm going to switch colors to yellow. So the very first thing, of course, is the parent graph. Otherwise, we'd have nothing to transform. But then second are reflections and dilations. Right? So you can either reflect and then dilate or dilate and reflect. Those two don't matter, the order you do them in. Or you can do them at the same time. Right? And I'm going to show you how to do them at the same time. And a little reminder, if A is greater than 1, then the vertical dilation, we have a vertical dilation or stretch by a factor of A. Right? So the new y point, the new y values equal the old y values, which are the y values on the parent graph. Actually, instead of old y values, I'll say y values on parent graph. And then multiplied by A, whatever A is. Right? And that's going to be true whether we have a stretch or a compression. Right? So either way, we're going to be taking the y values of the parent graph and multiplying that times A. If A is greater than 1, then we have a vertical dilation or stretch. If A is between 0 and 1, then we have a compression. Right? And so we have a vertical compression. Right? So in this case, where we have a vertical stretch, our graph is skinnier. Where A is between 0 and 1, we have a graph that is wider. If A is less than 1, then there's a reflection about the x-axis, and there may also be a dilation. Right? The reflection about the x-axis, all the y values will become negative. So whatever the y values for the parent graph were, they will all become the opposite. And I'm going to put opposite. In this case, they'll be negative because all the y values for the parent graph do happen to be positive. But if this graph had y values that were negative, then they would become positive. All right, so here we have all of our transformations. All right, so A here, this is what's going to vertically stretch or compress the graph. So all of that top part goes to A. Our horizontal translation is what's added to X. And as a reminder, if we have X minus a positive C, then we're going to shift to the right. If we see plus, what that means is that we have X minus a negative C, and we're going to shift to the left. The vertical translation is what's added in, right? And we usually see it at the end, right? But we could see it at the beginning, right? So it's possible that it could be listed as this, right? It is acceptable to have the K first, and then the A times f of x minus h. All right, those could switch. Right? It's traditionally, we put the K at the end, but it would be the same equation if we put it first, and that would be the vertical translation. We're not going to be dealing with reflections about the y-axis. Actually, if you reflected about the y-axis, you'd have the same graph because the parabola is symmetric about the y-axis. It wouldn't be true for some other graphs. We will see that when we get to square roots, but it doesn't impact parabolas at all, right? But I leave that up there because we will see it in the future, just not in this lesson. All right, so we've gone over horizontal translations, and a reminder of that the negative is with the is in the equation already. So the sign is going to be the opposite. So when we see a minus, that's a plus, and it moves to the right because it's a minus plus minus a positive c. And when we have minus a negative, when we see a plus, that's really minus a negative, and the graph will shift to the left. All right, so we have gone over all our different transformations, and this one here just doesn't apply to parabolas. Think about it. If you squared a negative, you'd still have a positive. All right, so now let's do some graphing. These are in your notes. Everything is in your notes, including the steps. All right, so that you weren't trying to write. I put them in there for you. All right, so we're going to graph two that have dilation, possibly a reflection, and a vertical and a horizontal translation. And my steps are color-coded. Your steps aren't color-coded. Of course, you can always use a different color pen and just kind of, put a little dot in that color next to the step. So in blue, I'm going to graph the parent function because that's our first step. Right? And as always, same points. 0, 0. But I'm trying to, here. I'm having trouble seeing the x-axis on this. It doesn't really stand out on this graph. But there it is, right in between all the 2's. All right, so 0, 0, 1, 1, and negative 1, 1. 2, 4, negative 2, 4. 3, 9. Negative 3, 9, and connect with a nice smooth curve. Oh, and that is looking pretty good. All right, so that's step 1. Step 2, we must do the dilation reflection first. So remember I said that the y values from the parent function are going to get multiplied by a. We can do this right here on the graph. We don't even have to. It's easy to do it in your head. If you want to write it down, you can, but it's actually really easy to do it in your head, and I'm going to show you. All right. So for graphing, this one only has a dilation, no reflection. We're going to keep the x, but we're just going to change each of the y values. All right. So the x values for those 7 points will stay the same. For the y values, we're just going to take whatever it was and multiply by a. In this case, a is 2, so we're going to multiply all our a values by 2. So I'm going to start right in the center. If I multiply 0 by 2, I still have 0, right? So it will still have that value, 0, 0, until we translate. If I multiply 1 by 2, we would have 2. So instead of having a 1, we're going to now have a 2. And the same thing over here, right? Because they're both 1. If we multiply 2 by 2, 4 by 2, there's no 2. If we multiply 4 by 2, that would be 8. Right? So now we're going to have 2, 8, and negative 2, 8. And at this point, you might be saying, hey, what about 9? Right? So 9 times 2 is 18. That doesn't fit on the graph. Well, if you've got points that don't fit on the graph anymore, just forget about them. Right? So we are not going to be able to put any more than 5 points on the dilation because it's going to be off the graph. Right? So actually, let me write down in blue that this was y equals x squared. And then in green, we're going to connect. Right? So when we're graphing with using transformations, we're going to have one graph for the parent graph. And then we're going to have one graph for the dilation reflection. Right? And the green graph here is y equals 2x squared. Right? We've just doubled all our y values. And notice our graph is skinnier now. Step 3, we're going to translate. We're going to graph the vertex and translate all the points. All right? So now if we look at, and I'm going to write down our translation here. If we look at our equation, y equals 2 times x minus 6 squared. Minus 6 means we have minus a positive 6. So our graph is, and I'll write it over here, we have a horizontal translation. And the horizontal translation is 6 to the right. I'll just put 6 units right. I don't know what happened to my S there. 6 units right. Then we have 3 added to the whole function so that we have a vertical translation. It's positive. We're adding a positive value, so that's going to be 3 units up. So now all we have to do is take those 5 points, the 5 points on the green graph, all right, the one we've already dilated. We're going to take those values and we're going to translate, right? So we're translating dilated graph. So add this part to your notes, because you don't want to take the other graph, otherwise you will miss the dilation. All right, we're going to combine all the things together. All right, so 0, 0 is going to move 6 to the right and 3 up. So now that's going to be at 6, 3. This graph is just going to, my 5 points are just going to fit. All right, so now we're going to move the next 2 points, 6 to the right. So 1, 2, 3, 4, 5, 6, and up 3. 1, 2, 3. And same thing with the other green point, the other point that's at negative 1, 2. 1, 2, 3, 4, 5, 6. 1, 2, 3. So notice the shape is already starting to change. So instead of being, if you remember, they were just kind of 1 apart, right? And so like kind of diagonal 1 there. Now they're going up 2. And let's move the last 2 points. So 1, 2, 3, 4, 5, 6. 1, 2, 3, way up here. And 1, 2, 3, 4, 5, 6. 1, 2, 3, way up here. So this one just fits in on the graph. And the red graph is y equals 2 times x minus 6 squared plus 3. Right? That is our graph. Right? So we've dilated it and then we've translated. Notice it's the same shape as the dilated graph. It's just been shifted 6 to the right and 3 up. Let's add the domain and range. We can just put it right on the graph. So of course the domain, negative infinity to infinity. The range, the graph has been shifted up 3. Right? So shifting it 6 to the right doesn't change anything, right? Because the domain is all real numbers. It will eventually keep going, getting wider and wider and wider, and every x value will be in the domain. But the range is limited because the vertex has been shifted up 3. So our range is 3 to infinity. And there we go. Let's do the same thing with the other graph. All right, so the first thing we're going to do is we're going to graph the parent function. All right, so 0, 0. It's a little bit off. 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4, and 3, 9, negative 3, 9. All right, so, and then we'll connect our points. Other than missing 0, 0 just a tad, just the tiniest bit. Oops. No, I don't want to clone you. I just want to move you down. There, that looks better. All right, so there's the graph of y equals x squared. All right, so we've done step 1. Step 2, we need to dilate and reflect. Now this gets a little busy if we have 4 graphs. So let's do the dilation and the reflection at the same time. How you can do that is, notice how we counted, right? So if our graph, if the point is going to be twice as much, in this case it's going to be half as much. So instead of counting half as much in the positive direction, we'll just count half as much in the negative direction. And you'll see what I mean when we start doing that graph, because now we're going to do it right now. We're going to do step 2. All right, so of course we're going to keep x, we're going to multiply the y values by a. In this case, a is negative 1/2. You know, let's write that in there. All right, just so that's clear. Actually, no, I have it in there. Never mind. I put it right there. All right, so a is negative 1/2. So our y values are all going to be opposite and half as much. Well, you multiply 0 by anything, it's still 0. And so that one didn't change. So instead of having our next y values are at 1. Instead of being at 1, they're going to be half as much at negative 1/2. Here in this graph, we have no trouble fitting points in. All right, so our next values are going to be at 4. Instead of being at 4, they're going to be half as much. They're going to be at 2 and negative 2. Right? It's going to be half as much and the opposite. All right, so instead of having a point here up here at 4, we're going to have a point here at negative 2. So notice we kept the x. We just made the y's the opposite and half as much. Our next values are at 9. So instead of being 9, it's going to be half as much and negative. So half of 9 is 4.5. So it's going to be now at negative 4.5. Oops, my point's just a tad off. If I make the points big enough, whoops, I hate when it does that. All I want to do is move it. It's like it doesn't know what it wants to do. There we go. All right, so now we're going to connect our points. So notice our graph is wider. And I'm going to try and shift my graph a little bit. My graph's in pieces. Yeah. My dots are getting a little bit big. You know what? I'm just going to make that nicer. That one dot there is just a little big. It's taking up like half the space. There it is. All right, now I'm going to connect. It's like trying to graph with crayons. These pens are so wide. So it should just look like a reflection. That looks much better. Reflection and dilated. So there we have the graph. This would be the dilation and the reflection only. So this is y equals negative 1/2 x squared. Right? That's what the graph of negative 1/2 x squared looks like. The x values are, the y values are half as much, and they're all negative. And now into the last thing, we're going to translate. Right? So we have a horizontal and a vertical translation. All right, so when we see plus, we know that plus is really minus a negative 4. All right, so our graph is going to shift 4 units left. We also have a vertical shift because we have a value added in. All right, we see we have a negative 3. Negative 3 means we're going to go 3 units down. Should have made the reflected graph go up and the other graph go down. But this graph here will have no trouble fitting in, even if we have to go down. All right, so we're going to take those 7 points, and we're going to move them all 4 to the left and 3 units down. Right? So our vertex, 1, 2, 3, 4, and 1, 2, 3. The vertex now is at negative 4, negative 3, and we can see that from the equation, right? That our vertex is at negative 4, negative 3. And then we'll move the next set of points. 1, 2, 3, 4, 1, 2, 3. So now it's halfway here. Well, it's trying to be halfway here. And we'll move the other point. 1, 2, 3, 4, 1, 2, 3. Both of those are trying to be halfway. They're not succeeding. See if I can get it to move good. I was afraid I was going to get the graph to move instead. But I'll get that box. I say that's probably good enough. All right, let's move the next pair of points. 1, 2, 3, 4, 1, 2, 3. Man, the orientation on the left side of the board. And 1, 2, 3, 4, 1, 2, 3. Aha, I figured out how much it's off. And now 1, 2, 3, 4, 1, 2, 3. We're going to move our last pair of points, and that is just not in the right spot. My pen was, but my dot's not. So 1, 2, 3, 4, 1, 2, 3. Right here, halfway. Just make the dot huge. It'll fit in where it's supposed to be. And then finally, 1, 2, 3, 4, 1, 2, 3. So that dot is supposed to be halfway. I just made it huge, try and get it to be halfway. All right, so now we connect. Oh. The other problem is I can't, right here, my shadow blocks. And so sometimes I don't see where I need to head to until I'm there. And then I miss the point. We'll take that. There we go. So there's our graph. Y equals negative 1/2. X plus 4 squared minus 3. And there we go. Those are all the steps. All right, so when we have a dilation / reflection and translation, we're going to have 3 graphs. If there's just a translation or just a reflection dilation, there'll be 2 graphs. Let's write in the domain and range. So the domain, -infinity to infinity. This graph is shifted down 3, so the range is -3 to, excuse me. Now, as it shifted down, it is reflected. It is -infinity to -3. So -3 is the high point on our graph. So -3 is as high as that graph goes. All right, so thanks for watching this video. In the next video, we're going to learn how to determine where a graph is increasing and decreasing. And that's going to be the end of this lesson. Thanks for watching. Bye for now.